You're listening to a podcast from 702.
702.
The Naked Scientist.
Dr. Chris Smith is here for the Naked Scientist section, and you guys can get in touch with us 011 8830702 and the WhatsApp line 0727021702. Get all of your science-related questions through. Doctor, happy Monday. How are you doing? Doctor? Doctor, are you on mute?
There we go. I was just unmuting it when you came to me. It's a happy Monday very much indeed here because it's Bank Holiday Monday. It's a public holiday number one. So we're all enjoying a very relaxing Monday, and the weather is nice as well, which is good news as well. So I'm in a good mood.
There we go. All right, let's jump straight into all of our science-related questions. The lines are open. We've got Rian in Garsfontein, Pretoria. Rian, how are you doing?
I'm doing well. How are you?
Good. Go ahead.
Yes, the question I want to ask is related to the creation of the universe. In the previous show, Dr. Smith said that energy and matter is interchangeable. So matter, if I understood it correct, stems from energy. So my question is, where did energy come from with the Big Bang?
The answer is we have no idea. There's only so far back we can see in time because we have to infer what happened before the point at which we can see further back. And there are various messages that come to us written into what we call the afterglow of the Big Bang, the cosmic microwave background radiation, which is effectively information which is still in the universe, imbued into various forms of light which are still reaching us from very early in the universe's origins. But what we can't answer is what happened to create the Big Bang. Now, there are lots of theories, but the problem with theories is that we can't test them because we can't see objective evidence to test them yet. But it may be that we will get that evidence in the future, or we'll find other ways to test these theories. But we just don't know. Maybe, as one theoretical physicist put it, that our Big Bang is effectively the arse end of a black hole in another universe, which is spawning this universe. So maybe a Big Bang in one universe is the material which is coming out of the other end of a black hole that started life in a different universe. We just don't know. But you're absolutely right that energy and mass are interchangeable. Einstein taught us that with the equation E equals mc squared, where E is energy and m is mass. C squared is the speed of light squared, so that's a constant, so therefore energy and mass are interchangeable. And we know that the universe began life about 13.8 billion years ago as a very energetic but extremely compact and small entity, which via some mechanism came into being, expanded incredibly quickly and grew very, very fast in its first fractions of a second of existence, then slowed down. And out of the material that was produced in that process, it cooled down as it expanded, because as things get bigger and more spread out, the temperature falls, and you get to a point where material begins to exist. But how you get from this supercharged, very hot material to the particles that we have, and then how those particles then form bigger particles, that's very much conjecture. And your guess is as good as mine.
Thank you so much, Rian, for that question. Now, Doctor, I came across something speaking around Gary Nolan, PhD professor at the Department of Pathology at Stanford University School of Medicine. Now, I don't know if you saw this at all because it only came out yesterday, but what he has claimed is that aliens have not only visited Earth, but that they have been here for decades and continue to be here. And he made some of these comments during some session around UFOs. I was curious as to your science considerations to what he's been saying, because while some might say there is no scientific proof that aliens exist, is there scientific proof that aliens do not?
I haven't seen the comment or the commentary or the piece of communication that you're referring to, but taking a step back for a moment and just thinking about this, we know roughly how big the universe is because we have that age limit for the universe, which we have independently tested in a number of different ways, of about 13.8 billion years. And we know that our galaxy, the Milky Way galaxy, is quite an old galaxy, but that our planet is a relatively young planet, about 4.5 billion years old. So therefore there will be other stars, there will be other entities out there in the emerging universe which are older than ours, and therefore if life got started here relatively promptly, which it appears it did within about 500 million years of the Earth forming, we have evidence that there were life processes taking place. If we assume that they started here, and that's a big if, because it might be that perhaps life processes started elsewhere in the universe and got planted here in some way, but we'll put that to one side. Let's assume that chemistry caused life to happen here on Earth because the environment was just right for that to happen. Then the likelihood is it could be just right somewhere else. And then it becomes a numbers game. Well, how many opportunities are there for that process to happen elsewhere in the universe? The answer is there are a huge number of opportunities. The Milky Way galaxy has got something like a couple of 100 billion stars in it. And that means that around each of those stars, there will be planets a bit like ours in many cases. And if there are a couple of 100 billion stars in this galaxy, and then you ask, well, how many galaxies are there? And the answer is a couple of 100 billion. Very quickly, you've got billions and billions and billions of planets out there, all with an opportunity to be the origin of life like the Earth was. And when you start to play with these sorts of numbers, you see that the likelihood of life not existing elsewhere in the universe is pretty low in the grand scheme of things. So then you move the question on to, well, how likely is it that they are here? Well, if they were in existence long before we came into existence, because they were born on a planet that formed much, much older than or before ours did, then they would have had many, many thousands, millions, billions of years of evolution to go through and technological advancement. So it's plausible that they could have cracked the problem of the size of space. This is the issue, because given how massive the universe is, just our own system, this radio program, if we were to beam it to Pluto in our own solar system, it would take 6 or 7 hours for someone to listen to every word you said. If they were listening on Pluto, the program would be 6 or 7 hours old before someone actually heard it. That would be one difficult phone-in to conduct, wouldn't it? That's just our solar system. In our galaxy, it takes light 100,000 years to go from one side of the Milky Way to the other, and that's just this galaxy. There are billions of galaxies, but they're separated by vast distances of intergalactic space. So you've got to have a way of travelling across space readily and doing that in a relatively short space of time, because if it took you that long, just as light is taking that long to get across space, we can see light that's only just getting here from some of the oldest stars in the universe, billions of years ago. So given that we believe that you can't break the speed limit of the speed of light, if our aliens were coming the conventional way and travelling up to the speed of light, say they could, it would still take them billions of years to get here. So they must have cracked an even bigger problem, which is how do you bend or warp space so you can travel vast distances very, very quickly, or you come through some other weird dimension that means that you don't have to travel those huge distances. And that then begs the question, well, if you can achieve all of that, what on earth could you possibly need to come to Earth for? I mean, is this some kind of alien tourism
Yes.
where you come to see what cavemen and cavewomen equivalently look like? Or evolution in action? What could you possibly learn by coming here that you couldn't learn if you've got physics so powerful that you can transcend space and time to travel the universe to get to a back of beyond place like the Earth? Why on earth would you bother? So I think there's a range of considerations. It's very unlikely that life came from within our own solar system that's as advanced as we are. We're probably the more advanced forms of life in our own solar system. Therefore, they've immediately got to travel between stars. If they can do that, we're into the realms of the argument I just made. So I think it's very unlikely that aliens with the ability to go across these vast distances would be bothered with coming here, because they almost certainly would have the power intellectually and scientifically to learn everything they needed to know about the Earth without having to leave the comfort of their own alien armchair.
Yeah, but they didn't have Tina Turner and David Bowie. Maybe they just came here to hear the cool music we humans make.
They would, wouldn't they? Because if they have the technology to do all those amazing things in physics and travel vast distances and see and reach out over vast distances of space, then they could have been watching Tina Turner for years. If they've got good taste, they would do.
Ah, I see. What a good answer. I absolutely love that. All right, let's go to Jabu in Mkonde. Jabu, go ahead.
Good afternoon, Dr. Chris and Lebu. This is Jabu. I'm happy to be on air today. I'm your loyal listener. Thank you very much. Yes, there is a general understanding that humans come from primates. And my question is, if that is the case, why do we still have primates? Could it be that their specific ancestors were difficult to embrace change, and our specific ancestors were embraced change wholeheartedly? That is why we exist as humans, and they still exist as primates. Thank you very much.
Thank you so much, Jabu. And that's a good question: is why did we evolve and they didn't?
This is quite a common myth conception that we evolved away from some common ancestor that then left behind our other close relatives. That's just not true. We shared an ancestor with the animals like monkeys, chimpanzees, bonobos about 6 million years ago. That's when we last all shared an ancestor. So in other words, what that means is there was a creature that we had 100% genetics in common with, and it span off different lineages of animals. One lineage became us, ultimately. The other became some stuff that ultimately became chimpanzees or ultimately became bonobos. It didn't spit out chimps and spit out bonobos and then say, right, you stay there and do nothing for, in evolutionary terms, the next 6 million years, and these other fellas, they're going to turn into, via other intermediates like Australopiths, and then early, more primitive forms of Homo, our lineage, and then us. They all evolved. Everything continued to evolve, just as life has continued to evolve in every domain on Earth, and it's turned into the pattern we have today. And the animals, the chimpanzees, are not what they were 6 million years ago. Otherwise, they'd still look like that common ancestor and be no different from bonobo. So evolution has continued, but it's just that the way evolution works, it's natural selection. There is pressure from an environment that drives things to change and adapt, thanks to genetic changes, genetic mutations, which give us the ability to add diversity and then be selected by pressure in the environment to improve further and further. And it so happens, if you don't fiddle with an organism, it will, once it's become very, very well adapted to its environment, it won't feel much more pressure to carry on changing. And so chimps would have been very much at home, very, very well suited to their environment and extremely effective at what they did. So would bonobos, so would gorillas. And it's only us coming along and damaging the environment and robbing them of their home that has meant that they are now regarded as endangered or not quite as successful. But if you didn't have those kind of pressures, then they would still be a very successful species. So you could argue, well, evolution's done its thing. It's filling the niches on Earth, the opportunities to exist, which are otherwise unfilled. And that's what every species is competing for, its patch of turf to call its own on Earth.
Thank you so much for that question. Paul in Linwood, go ahead.
Hi, Lorel and the good dog. So I got one question. So what I want to know is why when you have not bathed, and maybe you bathed in the morning, now it's late, you feel lazy, you don't want to, and the moment you think about it, your body starts to itch.
Paul, I feel like our black grandmothers brainwashed us by saying Ditsila Dialoma. I don't know if that's a real thing or is it psychological, because I also know that sensation Paul's speaking about.
What's the translation of that?
Oh, so saying that dirt makes you itchy. So I feel like in my home when we're growing up, they would say these things like in winter, even if you're like, I'm so cold, they'd be like, because you didn't bath. So there's certain things that you'd be told in the home that, okay, dirt will be itchy. So now I think we were brainwashed into believing that when we haven't now had a second bath or a specific bath, and we think about it, we start itching. But in my mind, I'm like, that's just because we were told it doesn't mean it's real itching. I don't know if that's true.
I think you're right. I think because we have been brainwashed as we're growing up that there are certain ways of doing things. If you depart from that way of doing things, you automatically feel a bit uncomfortable. And it's a bit like if we start talking about yawning, everyone suddenly feels an instinctive urge to yawn. If you start talking about things that make your skin crawl or a bit itchy, everyone's thinking, oh, actually, I do have an itch. I'm going to reach and scratch now. And it's one of those psychological things. It makes you think along certain lines. And just like the placebo effect or the nocebo effect, where you have an expectation about the outcome of taking a drug or treatment, and it affects how you feel in the aftermath, I think this is very, very similar. That you think, I feel grubby because I haven't had a bath. And you're not really any grubbier than before you had that thought. But once you've planted that seed in your mind, it's like a contagion, and it takes over your consciousness and makes you think, I just don't feel comfortable. It's a bit like, I really hate going out in the morning if I haven't had the opportunity to clean my teeth. Even if I know that my teeth are fine, if I haven't had the chance to clean my teeth, I just don't feel all is well with the world.
Yes.
Reach for the toothbrush, get the toothbrush. Now everything's good. I can face the day. Same with sort of brushing your hair or thinking, I just don't feel smart. I feel like I've put on clothes. I don't think I look smart.
Yes.
It's that sensation, I think, of unease because you're breaking the mold of what you're used to and what you feel socially is expected of you. And that makes you feel that little bit more uncomfortable. I think that you're right. It's that brainwashing that goes on societally and in the family and educationally as we grow up.
If it keeps people washing, then keep telling your children that. Just saying. Max in Lindbro Park. Hi, go ahead.
Hi, how are you?
Good, thanks, and you?
Good, thank you. Oh man, this is my first time on radio.
Welcome. We love first timers. Welcome.
I'd like to give a shout out to, no, just kidding. I would like to ask the naked scientist. So I have a son who has just been recently diagnosed with autism. He's just 2 years old. So I just wanted to understand the relationship between evolution and autism. How do they blend in together? Why does it happen? And yeah.
That's a good question. And maybe then, Doctor, that could be expanded to other conditions that fall within that category in science.
Well, first of all, thanks for calling us and welcome to the programme, being it's your first time. Big warm welcome. And I'm sorry to hear that presumably your young child has had a bit of a problem and it's probably made your life a little bit tricky. This is a difficult one to answer because it's only in recent years that we've really got to grips with what happens when children develop autism, or what we tend to talk of disorders on that spectrum, a group of connected conditions which seem to vary in terms of their intensity. We're beginning to understand a bit more about what's going on with people who have this, and it would appear that it's to do with how different regions of the brain connect to each other. It's not that there's something structurally different about the brain, it's functionally wired up slightly differently. And when people do tests in individuals who have autism or Asperger's, they're on this spectrum of things that range from very, very mild to more severe impact on how a person functions. You tend to find that different parts of the brain are connected slightly differently to each other than if you were to take a person we regard as, in inverted commas, normal. So it would appear that something is guiding the brain to wire itself a bit differently in these young people, and this has a knock-on consequence for how their brains function. But in the same way that we think about what do we call normal, we tend to say, well, there's normal, and then if someone doesn't fit this very narrow definition, we call them abnormal. We're beginning to change our views of all this now, where we tend to think that actually the way that nature puts us all together, we are all very different indeed. And most of us conform to a quite narrow definition of what people call normal. But there are people at the ends of those extremes who are not wrong or abnormal, but they just function a bit differently. And so we're thinking, well, in fact, life is all about diversity and difference. And sometimes some people who may be wired up slightly differently have the most incredible intellect, which gives them the ability to see things from a perspective that no normal person could see it. Let's take dyslexia as an example. There are people who cannot or really struggle with language because they have dyslexia. And this is a reflection on the way that their brain is wired in a certain way. It makes it difficult for them to do things that a person who says, oh, well, I'm normal, can do easily. but they may have the most exquisite ability to manipulate numbers in their mind's eye. And because they are that little bit different, they may struggle with one thing, but have, on the other hand, an extraordinary skill or ability on the other hand. And I think this is sort of where it comes into it from an evolutionary point of view, that evolution rolls the dice. Natural selection then picks out the people who have extra opportunities and skills in certain environments where they can really flourish. And it's all about, in the modern era, finding those environments where people who have certain skill sets can really flourish, and where we can support perhaps the other things that are one of the less good strengths, one of their weaknesses that they have, because they are better at other things. So it's more about supporting people and trying to give them the best quality of existence and the best relationship with the world, rather than write them off, which is what we used to do historically. And, we're very sad to have done that.
Thank you so much for that question. We're going to have to leave it there. All the best, Max.
The Masked Singer South Africa is here. Join me in Pop-Ups and the panel of detectives Jay Something, Somizi, Sitelo Shozi and Skumba as we try and guess